I suppose the first way of introducing it is I actually am a runner-up today for the second longest presentation title. The guys from McAfee just beat me by 7 characters. Anyway, I'll give you a bit of background about Healthdirect. Healthdirect Australia designs and delivers innovative services for governments. Effectively, these are digital and telehealth services available 24/7, and we vet every piece of information that ever goes online through clinical governance, not just data governance. And this allows Australians to manage their own health and health-related issues. In effect, we're a lot like a Mayo Clinic for Australia. How we impact our health sector is through both web and telehealth services. We help over 3 million people a month, and we're ranked from our website #1 in health literacy in Australia. So we're kind of the Dr. Google, if you will, in Australia. And we also operate something which is a national core piece of infrastructure. It's the National Health Services Directory. It's responsible for integration and core integration of healthcare professional information into hospitals, clinical and patient systems. We do over 1 million requests a month against that. I mean, these aren't massive numbers. We're not Twitter by any means, but this is health, and at the end of the day, that's the sizing of our population that we deal with. There's a bit of background for the National Health Services Directory. Effectively, I like to call it like it's our AD for Australia, in that we've got healthcare organisation or OUs, we've got users, which are effectively our practitioners, and groups in the way in which they activate their services and what they offer. These are used within hospital systems, electronic medical record systems, clinical pathway applications, our telehealth services. We provide API integration across the healthcare sector for all sector participants to integrate via APIs. And we provide sector-wide analytics and reporting. And I'll expand a little bit on that because we do support health planning, and we're widely used for analysis and health planning in Australia. One of our partners is HealthMap, which is there to basically provide a level of population health statistics. At the click of a button, you're able to drill in and find particular services and their coverage and the amount of consumption that's there. Helpful for demand forecasting for health. And also a unique piece that we tend to offer in Australia and probably anywhere in the world is the Royal Flying Doctors Service. And this is for regional and remote. We are a big country after all. We can't actually have hospitals in the middle of nowhere, in the middle of the desert, those sorts of things. So we actually fly out doctors, and we end up providing a mechanism where we can locate regional and remote services and provide demand forecasting around those areas and dispatch our flying doctors directly to those points of care. As a national service, of course, we've ended up with landscape changes. As you do, the business grows as well as the health sector landscape changes. We've seen the Australian healthcare sector promoting the adoption of standards such as HL7, the FHIR standard, Fast Healthcare Interoperability Resource APIs, and also provider directory federation. So we're federating this information more and more across the healthcare sector with open data standards. Prior to this, they were far more feudal, I suppose, in the way that our particular systems work together. We also had effective business drivers pushing us as well to make better use of the funding that we have available. And I think that's an obligation for anybody who's either not-for-profit or in the public sector to make best use of the taxpayer dollar and make it go further. In order to be able to meet some of these, we needed to change our architecture. We needed to scale to meet certain objectives for what we defined our future success to be. These included the development of new analytics capabilities to support, obviously, the healthcare planning side of things, but also in terms of our own analytics to understand the data quality of what we produce and make sure then that effectively when we improve the data quality, what we look at it to be is a rising tide that lifts all boats within the healthcare sector. And due to regulatory changes, I mean, most companies as well as most countries have seen new data privacy regulations come upon them. And we're seeing exactly the same thing. And with information security going across a broader set of use cases and through federation, we saw that we needed to actually adopt a better way in which we do our data security as well. Now, in order to be able to address these landscape changes, they weren't without challenges within our existing environment. So One first challenge that we saw was the data quality. And we wanted to improve not just our data quality, but the data quality of what we share across the sector. And obviously to provide a level of governance over the top of that. And this is, I suppose, challenged in the way that sometimes the systems of record are not necessarily available. We may not get feeds from our, say, practitioner registries on a daily basis. It might only come monthly. Our Medicare systems provide it monthly. So we don't actually have the availability to the data to improve it within that one month window. And often access is guarded by legislation. So not just any company can come in and access this information unless it is legislated that it's for the purposes of healthcare. We saw also that there was no single source of truth. In other words, across a diverse healthcare sector, that no one really holds a source of truth. They all hold copies, if you will, at different points in time. This high variety of data sources occurs at a federal level, our state levels, both in public and private hospitals, within our other commercial vendors, those which provide electronic medical records as well, which isn't great in the way that we would like to provide healthcare when medical records are not necessarily held accurately. At least at the practitioner level, the person who's servicing you should be as accurate as possible. We also came across the challenge, I suppose, of health domains. Health domains are vastly complex. These are complex ontologies, taxonomies, thesauri and code sets. I mean, we adopted mesh from the US and we adapted that and localized it, so we added a layer of extra complexity on top. We use SNOMED as well for common terminology, and then we've got an Australia-New Zealand standard as well that overlaps with that. So when we talk about reference data, these things are very, very complex to interleave or to crosswalk amongst themselves. This leads to, I suppose, other areas of concern such as record linking. There's no one system that holds an identity. So one system might hold a practitioner's identity in one particular quasi-identifier, in other words, custom identifier, compared to another. There's no one hospital record that identifies a doctor in the same way as another. So this is a massive problem when you're trying to amalgamate this information, make sure that it's actually accurate and reflected upon at that point in time. We saw as well disjoint data governance, so not just ourselves having data governance concerns, but across all of the healthcare sector, there's individual pockets or silos of data governance. And it's not a network of data governance. No one person agrees with another about what the identifier set should be, whether it should be alphanumerically based or whether it should be a sequence, etc. All of these things become impediments to us. And it limits, I suppose, a comprehensive view of what the outcome and costs are within the sector. Another challenge that we saw because of this, even internally ourselves, we had multiple subsystems. So we have file systems with different sets of data, different ETL systems. We had transient data storage, which sometimes was probably, you couldn't call it transient, it was actually just sort of more persistent. It was just an area that it stayed in. We had multiple databases, obviously with multiple schemas, and we had duplications across our search engine indexes. This led to a lot of read inconsistencies in terms of an internal challenge that we were facing. So contentions between read and write intensive processing, data out of sync between one database to the next. There was never one particular point in time that you could actually see where these things were harmonized. Our large batch updates ended up, depending upon the type of supplier of that data, often if they were low quality, that led to process inefficiencies and overruns so that, instead of it being processed within a 24-hour window, it became 48 hours and then, multi-day type processing. And because of these silos, there was no transactional understanding, if you will. There's no holistic end-to-end concurrency. There's no understanding between one set of transactions being propagated to the next system. And of course, coming back to the data access side, it was incompatible with our security boundaries. And one thing that we realized is that we don't underestimate the cost of security. The cost of data security, such as like a data breach, for example, at a global average, it's $3 million per data breach. In the US, surprisingly, it's 7.9 million, so probably a little bit more litigious. Anyway, just to put that together in terms of how that actually sort of fits it more as a mental model, if you will, it's kind of like a jigsaw puzzle. I have to take all of these different pieces and silos across the whole healthcare sector and aggregate those pieces, so act as an aggregator, pull the data together to make it cohesive, but also combining at a point in time where you can get the best and the latest version. And that actually requires us to scale. In other words, to increase our processing frequencies and to at least get to a point where the data can actually start to scale up to process what we call the size behind it. These processes would be up to 1 billion data points now. And this is because we're seeing new demands come on top of the system. As I said, the landscape is changing. People are asking us to include bookings and appointments. You can imagine how many time slots there are times the number of practitioners in your country and across hospitals, clinics, physicians, as well as the pricing information around that. We're aggregating this together so that you can actually understand where you get best value for money, for example. And eHealth transaction activity, as I was saying before, the sector is starting to promote better interoperability. And eHealth transactions are things like e-discharges from hospitals, e-referrals between two specialists, for example. And we're estimating that in this first year that it's going to be a terabyte of just that data alone. And in order for the broader use case, share that or federate that and interoperate, we're already seeing that our requests are growing at greater than 50% a year. So we're expecting this data volume to significantly increase over time, even though I don't have the current data size and scale problems. It's certainly going to turn into that within 1 year, within 2, even greater. And our existing systems were already under pressure. I mean, we had legacy systems, I suppose, hundreds of tables, dozen node database clusters, examples, multiple ETL frameworks, so we're using SSIS as well as Pentaho, and a range of other sort of more bespoke things that people had written over years. In essence, it was like an archaeological dig. We went in there and we sort of had a bit of a huddle together. What could we save or salvage from our existing system? What we found were, just legacy elements such as, I remember one guy finding a table that's 4 years old. It had one record in it. It was like in 6th normal form. We were wondering, where did that come about? Why would we have ever have maintained that? We also had a look at our ETL frameworks, and we just had jobs that were running. And if they didn't run, for some reason, other things didn't run. And they're only really there to do some strange piece of background processing designed 3 years earlier, which we now no longer understand its rationale or its reasoning, but it's still running in the background. Anyway, all of that sort of prompted that effectively the team and myself decided that we had to do something better than what we were doing. We couldn't salvage a lot of what we had. Obviously, the data is the asset, and we wanted to salvage our data, but we didn't want to salvage much of the system. And it's high time, due to the landscape changes, to make not just a step change, but a full evolution. So that led to effectively a change in architecture. And we adopted Databricks, and we developed a new processing pipeline. And part of this was that we actually moved all the system responsibilities. We segmented them into control planes, functionally aligned control planes, if you will. That way you know well where your componentry should sit and reside within your architecture. So for example, from a development level, we shifted all of our code changes, all of our data manipulation notebooks, all administration into code pipeline. And we do CI/CD processes now using things like the Databricks APIs to push those into a production setting. The Databricks control plane sitting within the Databricks account itself provides us with the data access requirements that we needed for securing our data, the content management side, so that we actually use a notebooking environment to make content changes in a controlled fashion rather than having a custom or bespoke UI or job. We've also then obviously lifted that out and provided analytics within the system. So in short, what we've provided is now a way in which we can provide all information coming into the system through one simplified, consistent integration point, which is effectively Spark structured streaming. So all data sources or all data producers will use the interface to basically supply it through a structured stream. Those structured streams are read by our Spark applications. The Spark applications themselves effectively are responsible for sourcing the information, staging it, and getting it into a gold ready state, which then flows on to the data consumers in a structured streaming way. So people can subscribe to the stream, the output stream. It can go directly into a relational database although we don't tend to use those anymore. Now that we're more document-oriented, they'll go into things like DynamoDB instead. And so you can actually use DB streams off the back of Dynamo for further subscriptions, such as other Lambda functions, which will do things like feed Elasticsearch. Business applications as well can be designed around those interfaces, and there's a consistent way in which they can also receive the latest data at the fastest level at which they could integrate before. So we don't wait for 24-hour batch processing windows. We don't wait for things to accumulate. You subscribe at the frequency necessary for your business application. We're sort of inverting the control, if you will, allowing the applications to come to the data and pull what they need as they need it. And this is all within an AWS multi-account environment, and allows us, I suppose, a new way in which we provide not just the management of that, but also how we integrate that within our whole ecosystem, our whole technology ecosystem. So just to reiterate on some of those things. So using Databricks Delta, we created logical data zones. I'm sure everybody's been seeing this from Keynote, et cetera, that, you know, the bronze, silver, gold concept. We have landing, raw, stage, and gold. What we do quite differently, however, is that we store data as is. So whether it comes in structured or unstructured, it gets pushed into Delta tables. And that's not to say that Delta tables don't do schema enforcement for us. But what we actually do is we use a metadata-driven schema, and we actually hold data within a nested structure within that table. So what it allows us to do is basically handle data consistently from every source all the time, so the interfaces stay the same, and then the applications act on the data with the knowledge around the data set that they know themselves best. So if it's from a particular Medicare source, for example, they'll do the mappings and they'll understand the actual schema that they're working with. So schema on read. In addition to this, what we've been able to achieve is the read consistency and the data integrity. And this is really important when it comes to actually being able to read the data consistently across all of the ecosystem. Now that's if I access the tables directly, if I'm doing analytics, if I'm providing the downstream stream for others to subscribe to. This gives us the level of read consistency and data integrity that we just couldn't achieve with these multiple systems that we were running before and the siloed operations that we had. We leverage Delta Cache. Delta Cache provides us with the frequent query access points. That's transparent and automated. So in other words, we don't do a lot of our own cache control. But if we do know about the data sets themselves, such as reference data sets, big taxonomies, coded medical records, etc., then they're candidates for this type of cache control. They don't change frequently, so slowly changing dimension sets are easily adopted into a Delta table and then cached at runtime for ease and access of querying when you're actually combining and weaving or merging data. The Databricks operational control plane provides our cluster administration and other management functions like access control, jobs and schedules. And the data control plane, as we saw before, just to remind over here, that runs within our AWS account. So the data's in our control, and that meets the appropriate security policy and regulatory compliance that I need within Australia. Other improvements that we saw, coming back to the applications here, what we're doing with the Spark applications is that we design these off continuous application concepts. So these are not just small, once-off type jobs or ad hoc pieces of processing. They're actually streaming versions of our batch ETL jobs. We understand what data that we need to deal with. We know how we needed to break it up, but we wanted to create a streaming version that could be multi-use. So one application processing all types of batch information and all types of stream information consistently. So that meant that we moved everything into event-based data flows. So all streaming input, Kinesis, S3, and Delta feed data up and down our pipeline. This actually provides us a way in which the data is managed at a state level and allows us to then shrink or increase frequency in which we're sourcing the data from. So ingestion frequency was smaller, and it allowed us to then have, it was more frequent, but it allowed us to have smaller data sets that we're processing at a point in time. This automation as well, this provided a level of automation of our release process. Because we're building applications themselves, they're exactly the same as any other Java application that we build. These ones happen to be in Scala. And so they still fit within our continuous delivery pipelines, all AWS code pipelines, serverless, and use the Databricks REST API in order to publish out the jobs. So quite easy change control and release management. And backing all of that is the recoverability through checkpoints. Obviously, within the stateful streaming side of things, we use checkpoints. And we have the reliability because of the actual streaming syncs into our delta tables for atomicity, if you will. Recoverability, I mean, we kind of have what we call a graceful shutdown and a disgraceful one in non-production. In other words, we can just turn it off in non-production as we do. I'll expand a little bit further on those continuous applications because it is a fairly new concept, and there are some things probably more in the background of what's happening in Spark as opposed to the foreground. What they basically are is they keep in memory state of the object sets. These include, in our case, comparable versions. So I can accumulate the particular object that I'm dealing with, a particular business entity, such as a practitioner. I can accumulate changes up to 10 or 12 different versions, for example, which gives me very fine-grained analytics and diffs and deltas and merges between previous versions, and also allows me to make decisions at runtime about the data quality. If I receive a late arrival of a particular event with a practitioner entity in it, I can actually substitute that using effectively just a decision tree piece of logic that says, use this practitioner because he's of better quality than the one that's just recently come in. And keeping those in memory is actually quite useful. It runs very, very fast then. We use stateful transformations. We flatten out all of the nested JSON structures that we receive, and we actually then operate our functions consistently across those. They are custom-built functions. In other words, people who know the data best will write the best validation logic. So it's not one size fits all for validation logic. It's agile with the business. If we get a new source, we onboard a new source within one sprint. Instead of it trying to fit within our environment, we actually do the inversion of control. We say, okay, well, look, give us whatever data you've got because I can't necessarily enforce my data governance upstream. So I take what I can get and then I act upon it ourselves. And we write our validation logic, and because they're in code, they're very quick to develop and they're very quick to release. And we provide aggregations of this data quality and the measurement of that. So we actually do append data quality against the record as it comes in. So we measure it at the point in time so that you can make decisions on it in memory and push it out for later analysis as well. So you can then do a big aggregate function on the outside, but you've also got your aggregate functions on the inside. And you can see some interesting insights between what happens at runtime and what happens over time. So one provides us more of a longitude or historical volatility, if you will, versus the implied volatility of what you've got in the current data set. Now, I'll give you a view of what that looks like from a data plane and data pipeline perspective. So effectively, these Spark apps interleave a multi-hop pipeline. They effectively push data across and into Delta, so they stream sync back into Delta. This also means that we write what we call data lineage off the back of that. We trim our Delta tables, so we keep those current as to the number of versions that we particularly want in history. And we write back those into archive tables behind the scenes, but predominantly the data flows downstream, allows us to do a staging piece where we actually then join it with the reference data, which then kind of gets it back into a standardized open data format. In other words, it adopts the open data standard. I can switch it between a SNOMED thesauri or code set to a recent FHIR API-based one. So I can take people from a legacy HL7 format into a new FHIR-based format and then produce it in either format, depending upon the consumer application at the end of the day. All data at the end is aggregated into a master gold table, if you will, and that's the full, complete historical data set. So analysts can come and access that as and when needed. They can derive greater and greater detail from it. You can take extracts and provide those things as different representations of the data. And with the lineage and audit, it provides me not only the data security, but it provides me a level of fine-grained view into the Spark processing applications. As I output the lineage, what I get to see is substates against that. So every time that it's entered into a validation function, for example, I'll record the validation's output. And I'll understand whether or not those particular attributes are actually getting more and more polluted over time, or they're getting more and more accurate. So depending upon the number of violations or warnings that you receive on your data quality levels, or whether it's an exception piece itself. So we partition this into an exception queue so that anybody working with the data administration and data operations side are able to come and access that data. They see what's in the queue, and they can make remediations on data that we know is supposed to be good, but we just get it from a bad source, and sometimes we have to do that when you're dealing with national systems. And what we do in terms of scale between this is that each of these Spark applications can be independently activated and deactivated. We use stream buffering in between, in other words. So if I need to do a change or release management process, I can take the application out altogether. It'll stream buffer, waiting for it to come back online. And once back online, we just suck the stream back in. Now that can be also made into a blue-green type environment if you're looking at a release management approach where you really do not want or cannot absorb downtime. We can also do blue-green on that. So in other words, stand up a parallel Spark application job and switch over our stream. So as soon as it's ready and it's up and ready to be processed, we just switch the stream to the new processing application. The other one drains down the session. Now, we also saw with this new architecture other improvements around the unified analytics, or the unification, I'm going to call it, between analytics and operations. And this is where we've seen probably the greatest benefit, bang for buck, to the broader organisation. Our data cleaning and matching algorithms have been made more reliable and predictable and measurable because we actually have access to it all in one central location. So we're able to act on this data very, very quickly and get the insights very, very quickly, experiment with algorithms very, very quickly, and we're not trying to then combine or coalesce data from multiple different sources and run jobs overnight to try and get extracts to do these sorts of pieces. It's just unified exactly what we wanted, the data as well as the point of access to the data. This means that not only are the data analytics collected at runtime and attached to the object attributes, but they populate the analysts' dashboards. So analysts can instantly see if a model is going wrong or if data quality is going down because of latent data loads, or we've had a change in someone else's system that's not been transparent to us. In other words, someone else has dropped the ball and their data quality has come down. We track our lineage and our life cycles through our data lineage objects. That gives us operational visibility of where our data is at any point in time. So we know where data is stuck. We know when something throws an exception. It might be our business logic that goes wrong, but we also know exactly where we have others who are providing us poor quality data that we want to push to an exception queue and actually alert them back, because after all, this is a sector participation piece. I want to see that people who are providing data to us are aware that some of the things that they provide to us are incorrect, or there is a later version that they're not using in terms of reference data, for example. Overall, the complex processes that we had previously were broken down into just 3 smaller steps, and each one has a check and a balance prior to its execution. So again, substitutability at runtime in order to be able to select which application, what update is necessary against it. That puts it into sprint cycles. So we're able to make sprint level changes. In other words, update the data validation rules and push those per sprint, or even at a higher release cadence. And I suppose one of the things I liked the most was I finally got rid of really complex admin UI. We had this huge admin UI that we had over 20,000 subscribers to, all trying to plug in data differently. And of course, we all talk about, manual data entry creates, many errors. We removed all the manual data entry. So it was actually quite a surprise that we saw in the sector. We said, look, we'll take that data entry away from you. You just give us the files. It was like a hallelujah moment where all of a sudden they went, so long as we don't have to do data entry now. And now we handle that within our own notebooking environments. We do our own validation checks against the data. If it's of poor quality, we just don't use it. We use the best quality data that we have available for that same thing at that point in time. And that's led to a significant cost reduction. The admin UI, it was about a 3-year journey, I think, and we never quite got there overall. Anyway, one of the things that we saw on the analytics side was a whole change in the way that our analysts work. We're able to improve our algorithm development and its usage. So by creating the feedback loop with data sharing arrangements, so as people are sharing data as opposed to entering data, these data sharing syndications, or federations, if you will, mean that I can actually influence some of those upstream people now. I can actually say, do you realize that you're using the older version of this particular reference data set? Or do you realize that this practitioner that you have in your doctor's table at your hospital, he's moved on, or he's now retired. And so please don't discharge patients to that particular doctor. That allowed us to start to improve not only the quality of the input, but also just the way in which the algorithms were running. They were really noisy before. They were looking like nothing ever fit well. Everything that we tried always seemed to go against us. Using this new approach to how we were developing algorithms gave us a level of version controlling around it. So what we were able to at least do is document them exactly within our notebooking environment. We archive data, we train and we validate that data at the same time. So we're all in one harmonious working environment. And that pushes out our data quality auditing, and downstream we get data quality reporting that we actually now provide back to the sector. And the sector is able to subscribe to that data quality. So they can say, I only want practitioners with a data quality level of completeness in their record, so right down to their contact information, of at least 80% or at least 90%. So if people are only using a level of communication to that practitioner through their electronic endpoint, they might only choose 4 attributes and have a lower quality coverage level or a lower quality completeness level. And by coverage, they might also say, I only want people within this particular state. And I only want them if they provide this particular service. And I only want them if they have completeness up to a level of 80%. So now people can selectively choose the appropriateness of the data set that they integrate with across the whole sector. Including, I suppose, what we get from this is the data is permanent and versioned. And it really is sort of playing into that Delta concept of the time machine. You know, we actually have versioned history and we retain that. And it's useful for us to see the historical change, the historical volatility across the piece, and sample better statistics off the back of that. And I'll give you an example of one of the algorithms that we did evaluate, which is a fuzzy match-based piece. And we saw immediately, well, why weren't we using this fuzzy match algorithm before? And it was really because we didn't have the quality of the data that we were able to now get from sharing arrangements. And we actually saw that this fit just absolutely perfectly, you know, compared to what we had previously. So we wouldn't see an excellent result like this in something like fraud detection or behavior prediction, but certainly when the only source that you can validate that someone's who they say they are is their name in many systems. If they might have a quasi-identifier somewhere else, but that might actually get re-established or re-identify the person. So in other words, the name changes, but the identifier stays the same. So what we tended to do is drop it down a level and say all systems are at least consistent with having names for their practitioners, for example, just as one example here. And then we used the analytics side of things. We saw that we were able to get the right results from this, and we kind of then fit this particular algorithm well to our data. Overall, it's given us certainly improved data processing. You know, our 95% fuzzy name match versus what we had is at least less than 80%. And it was also still dependent upon manual verification. So we still had, you know, at one point in time, over 30 people in a contact center environment calling people back to say, are you who you say you are? Which doesn't go down well when you're actually trying to ask people, you know, to validate some of their data. If you're asking them, are you Robbie, Rob, Bob, etc., people get a little bit, you know, annoyed with that. And I suppose the previous approach was to accept all of those values. And so then you had alias, nicknames, also known as, and you had just a proliferation of attributes which are effectively meaningless at the end of the day. The person is who they are registered, and you don't get to change your alias or your nickname on your passport, so we're fine with having a single name identifier. We also saw a massive improvement in terms of how our content management was going. So we moved about 30,000 automated updates per month compared to what we'd have to do biannually because we were doing manual processing. And our batch jobs were very ineffective, requiring further manual verification. Even if they were 80% complete, you still had another 20%. So you still had this overhang for every 6 months of verification. Since we shifted, well, it's a whole different story. So 20 minutes is our full load now, and I'm talking about the entire population. That's 20 million records that we load. So we're doing 1 million a minute now back into the system. And that is actually quite pleasing to watch, just to see that I can actually say, so let's set up a parallel environment and let's just dump a new full load and let's run some algorithms against that. So we'll do different analytics there. What we're able to do is also, in that load, we'll do obfuscation and de-identification and desensitization, so that you can actually work on a nice data set within a non-production environment. And it's a less than 20-minute load to get realistic volumes that you deal with in a production environment. So that's been a significant uplift for our data processing side of things. And it didn't come without improving data security, which I suppose in my background, I'm chief architect, but I'm also the ITSA, the IT security advisor for my organization. And I suppose they give me these jobs because they say, you know, the old saying, you know, if you want something done, give it to someone busy. Well, I also have to do my data security side of things. Now, Databricks provided the foundational security accreditations. So they did their part. There's HIPAA, et cetera. I'll go into that in a second. But I crosswalked their security compliance frameworks and localized them to the Australian regulatory frameworks. And if you are working across GDPR, for example, this is exactly what that use case looks like. You'll have a whole set of other standards or security accreditations, and you'll need to manipulate them according to, you know, localized things like GDPR EU. That provided a significant cost reduction in GRC, our governance, regulation and compliance. But what I liked about it was that it gave us a level of continuous data assurance. So within the same analytics processing environment, I've implemented security guardrails that monitor changes to access privileges. So I get to see if there's role elevation or conditional access changes. So in other words, there used to be fine-grained control over a particular table, now someone's made it more coarse-grained. Or I'll have security metadata that's associated, you know, security at the level of PII or PHI classifications, and I know when those things change, because they shouldn't change between, you know, a name is still a name. It's not going to be de-identified as such in a production environment. And we audit that also against data spillage and leakage, so I know where people are taking data sets and where they've gone. So what that has given us, I suppose, just as a quick snapshot, is a way in which we've secured it all. So from our side, the shared responsibility angle is that I am able to achieve what my government requires of me. I'm allowed to get that independently assessed, which is what the IRAP side is. And Databricks on the other side has given me all of the other security compliance and accreditation framework. So actually, I've minimized the amount of effort that I've needed to do to get my compliance. And that, I think, is a fundamental with dealing with any data or any data security, even if it's the financial side and PCI DSS. As I mentioned before, don't underestimate the cost of the data breach and what that does in terms of reputational damage as well. So on a final note, I'll just describe some of the other benefits that we saw. Now, coming from Australia, yes, we have a big country, but you know, we don't have the same scale of healthcare sector as the US. But we don't have to be big to see these benefits. I mean, this was driven out of strategic value, and it generated a new business model for us, a new way of working. That strategic momentum has shifted through other realization of business vision and technology transformation. So I've seen the transformation in data security, for example. With dataset transparency and explainable models, we're now actually able to go and provide this lineage and quality back to the healthcare sector, but as well documented, so people know exactly what it is, they can see what the measurement of it is, and they can choose what they want to subscribe to. So what's best for their particular electronic medical record system, their best information for their patient admin systems or their clinical information systems. We saw across the organisation a broader participation, so no one person being the one that holds all the knowledge, you know, the go-to guy that, you know, if he's not there, nothing happens. We now have seen that, you know, there's more value in our data when everybody's got access to it. And we transitioned, I suppose, our focus now on operational improvement rather than just the governance and putting gates in and requiring so much process and effort just to get through it. We're actually looking at, well, what do we do now to lighten that load? What do we do now to improve what we do operationally to get the efficiency levels up? Because that way you're running a more frictionless environment. And I suppose just in terms of the journey, we inked the agreement with Databricks in August 2018. Our system was running still in parallel with this. We completed the migration to Databricks in December, And since that migration, we've gone live in March. So by any means, to get 20 million records live with applications, with validation, with sharing, has been an incredible effort on my team's behalf, but also, thankfully, with I suppose it just reinforces the level of benefit that I've seen in terms of a unified adoption, unified analytics type approach. All right, I'm out of time. I'll hand it to questions now.
Well, thank you so much for all that. A round of applause, please, for Peter James. For questions, please feel free to come to the microphones. We have one on the left and one on the right here for questions for Peter. Again, you can please review the session in the app. You can go click the session and give your thoughts and feedback. But let me hand it over to Q&A.
Yeah. Hello, thanks a lot. It's a great session. So one is in terms of provenance you talked about, right? Every time you run a Spark job or transformations, do you have to record all the transformation delta that you did?
Yes.
Delta meaning the changes?
Yeah.
And that's also in a table, and then you keep storing it.
The part of actually one of the open standards and requirements under FHIR is that they actually, the FHIR spec is a provenance object. Yeah. And we actually collate and collect that provenance object. That actually becomes part of the metadata that we store with the record. So then we use provenance as the more selective source. So if, say for example, Medicare is a system of record, and I may as well choose their fundamental identifier as the provenance of where that attribute came from. So we understand the provenance of every attribute in the system.
Okay, so as part of that record, you save the provenance also alongside that record as you transform.
Yes.
And then the transformations, do they come from a rule or?
So we run multiple waves of transformations, if you will. So one transformation in an upstream environment might be a cleansing validation rule, which basically will say, okay, look, what I want is dates formatted this way. So we standardize up front. Downstream, we have other business validation type rules, which might be select source A and merge with source B to create at least 8 of the 15 required attributes, and then join with source 3 and 4 to get the remaining attributes together. So it's an assembly process, if you will. We often liken it to Lego blocks, where you've got a whole bunch of different Lego blocks, and you get 7 yellow ones because that's what you need, you get 8 red ones because that's what you need, and you merge those together in order to be able to follow the instructions to build a house.
Okay, thank you.
Question: how in aggregations, how do you identify bad sources and bad data? Like, how are bad sources and bad data identified in all this system?
Well, the Spark applications themselves determine. There's a validation framework that we're using, so we use Scala Z as well as CATS. But what we're actually looking for in there is business rule violations that would indicate poor quality data. An indication of poor quality data is like missing attributes. It's a fundamental. Another one might be that it's a non-interpretable date, not a number. They're sort of the elemental ones. However, we have more complex ones that say for example, the particular specialty that is assigned to a practitioner isn't actually mapped against a known reference data set or code. We also would compare whether or not that practitioner has been processed before and is actually doubling up in terms of where they're working, what we call the provider location. So there's sets of business rules that are applied at the data level as well, and they're bespoke according to the entity, the business rules around that entity, just like any other application.
Thank you.
Thank you very much for the talk. I have a question about the entity linkage issue. So you mentioned with providers you can use the name. This becomes much more complex with practices.
Yeah.
So could you speak to how you do that with the actual health entity, the hospital or practice?
So our domain model, I suppose, is supportive of how that fits together. And what happens within the practice is that one of the big reasons that we are more integrated more frequently with practices is that they hold things like bookings and appointments. They also will, for example, have practitioners who will work at one practice and move to the next the next day or even just that afternoon. Or they might change what they supply for, in the afternoon. So what we're trying to do is actually integrate with those practice management software suites. And so we actually are plugged into that environment. So there's a workflow module that sits inside. What we use is in our environment, a typical one is best practice or medical director. A workflow module sits inside there and also uses the same data as we provide it. So if the practitioner is no longer working there, or if the practitioner is only working within particular hours or whatever their appointments bookings are, we're taking that and feeding that back in and then distributing it so that the consumer can pick that appointment. So it's quite a complex piece that comes together to make that happen.